Hey, hi everyone. Welcome to another video in our AI predictive models series. So today we are going to go through reinforcement AI models and how this could be used for predictive modeling in trading. And we'll go through some of the examples where these models have performed better than the traditional models and specific examples. We'll go through and the details of those specific examples we'll go through. Okay, so reinforcement learning models. So, what are these? So, this is basically oral agents or reinforcement learning agents learn to trade by taking actions. So, like a human being, we learn trading, right? So, initially you trade and you will try to see how your strategy is performing and in different various market conditions. When it's bullish, how it's performing. When it's bearish, how it's performing. When it's sideways, how it's performing, and again during different time frames of its performing and so on. So that's how a human being will learn, right? But he learns by doing things and even failing and identifying those patterns, right? So similarly, reinforcement learning agents learn to trade by taking actions. So it basically it trades actions like it does a buy, sell, or a hold in a simulated environment. It does. We do it in the live environment, but this reinforcement learning agents do it in a simulated environment, and the main goal is to maximize cumulative rewards or the profit, which is even a human being's goal also. At the end of the day, we also want to maximize our cumulative rewards or profit. Okay, so that's what these do. So these behave pretty much like humans, but um, like trial and error method. It can be analog. That could be an analogy to what RL agents are doing. At the same time, learning mechanisms which human brain generally uses. So it's similar to that. So it learns by doing things and okay, and with a goal in mind. Okay, and that's what it does, and that's what these RL agents are. They learn to trade by taking actions in a simulated environment. They do in a simulated environment. In real environment, again, things could be a little different to simulated environment because the real environment has emotions in it. But again, agents don't have any emotions, so they perform pretty much same even in the simulated as well as in the real environment. Okay, so unlike other prediction models, this ARL reinforcement learning model learns how to behave under different market states through trial and error. So when we say different market states, it could be referred to, right, bullish state, bearish state, or a sideways state. Okay, so it learns how to behave through different market states through trial and error. Okay, if you want to set up these reinforcement learning prediction models, okay, what we need to do is first we need to define the environment. Which is we based on price data, technical indicators, and possibly sentiment. We need to give all the data to the reinforcement learning models: the price data, the technical indicators data, and the sentiment data. Then agent observes the state. Okay, so it observes this state and chooses some action. Okay, it takes either a long position or a short position, and it receives a reward, either a profit or a loss it will receive, and then it transitions to a new state. So this is how it will learn based on the data we'll give of the price indicator and sentiment. It basically observe that data and take an action and receive a reward. Okay, then we need to choose, once you set up all this, then we need to choose an RL algorithm, which is deep Q network is one algorithm, DQN it is called. It what is the does is discrete actions. Uh, the model is able to do discrete actions basically, like long and short is a discrete action. Long is one discrete action, short is one discrete action. SSE, PPO, DDPG, this is another algorithm. Continuous or discrete actions with policy gradient methods. So again, this is also a discrete action, but continuously it will do it. Okay, actor critic. This is another RL algorithm. It combines value function and policy learning. So basically, these will learn the patterns, or not patterns, but different states. Okay, different states it will learn, and in those states, through trial and error, it will know what worked and what did not work. Okay, so that's what it will know. So once this RL algorithms, the setup, the environment is set up, then you can train and backtest that. You simulate trading over historical data, and basically see the results, and you can adapt, do some changes to the engine to improve the performance. Yeah, coming to the performance highlights, SSC versus Dow Jones. These so SSC, that's a reinforcement learning model, outperformed the Dow. Okay, in bull market 2020 to 21, SSC has bet the benchmark returns. So it gave more returns than the benchmark. In downtown 2022 also, SSC dropped only 5%, minus 5% basically, and Dow was minus 13% during that time. So it's better two times than the Dow. DRL for cryptocurrency. DRL is again another reinforcement learning AI model, deep reinforcement learning model for cryptocurrency. When it was tested, a study was done on it. A study on 10 cryptos was done using DRL model. So after mitigating overfitting, DRL agents outperformed the equal weight and the market benchmarks. So again, it bet market benchmarks, and even across two crashes also it outperformed the market. Okay, so it's working both in the bull as well as the bear market. That's the beauty of it. Cascaded LSTM plus DRL model. LSTM is long short-term memory, and DRL is deep reinforcement learning model. So when it was applied to US Dow Jones Index and China's SSE 50, it surpassed baseline models on both cumulative return and Sharpe ratio. So it's outperforming the benchmark, that's for sure. Okay, and even it's working both in bull and bearish markets also. Futures trading, when it was done with DRL, so using DQN and PPO agents on 50 futures from 2011 to 19, it outperformed trend following strategies even after trading costs. After trading costs also, it outperformed the trend following strategies. So it is uh, doing good even in trend following strategies also. Alpha stock, so attention based reinforcement learning models. So interpretable RL for buying winners and selling losers. So this is stock picking basically done by AI. So reinforcement learning models can do stock picking also, and it could identify the winners and sell the losers also. And it was effective across US and China markets, balancing the risk and return. So one of the community Reddit user reported that backtesting the calendar year 2019, Sharpe ratio was 4.2, returns were 86%, maximum drawdown is 6.86% in versus SPY 30.86%. Okay, with this DQN plus LSTM plus CNN models. So the all these three models, reinforcement plus long short-term memory and convolution neural networks, gave a return of 86.3 percent with a drawdown of only 6%, 6 to 6.8%. Another built-in swing trading reinforcement learning bot using indicators and Alpaca experimented with DQN, DDQN, prioritized replay, and seeing progress in live testing. So yeah, so these models, the reinforcement models, are performing better than the index, the normal index, which the passive investing we can say, and at the same time they're working good in both the bullish and the bearish markets, and are good at identifying the trends also. Summary of performance metrics. So if you see SSC on Dow, it outperformed in upside as well as half in drawdown in 2022. DRL crypto 10 coins bet market benchmarks even during two crashes. Cascaded LSTM plus RL best in DJI and SSC 50, higher returns and sharp. Futures 50 contracts bet trend following after cars. Alpha stock RL plus attention, risk balanced performance in US and China markets. Reddit DQN plus LSTM plus CNN 80%, 86% returns with a sharp ratio of 4.2 and MDD of 6.9. User built RL model, active swing trading experiments in live conditions. So why these RL models work? Because they learn from the environment. Like a human being does, they learn. They're adaptable and they're dynamic. They learn from the environment, and they adjust the strategies over time. Risk sensitive rewards, so can optimize for sharp ratio or downside protection, not just returns. And strategy diversification, they support long, short, hedge to portfolio based and cross asset tactics. So that's why these RL models are very good. Challenges are overfitting could be there, so need robust validation. Crypto sample identified and discarded overfitted agents. Regime shifts could be there. Performance decrease if market trends change. Retraining is again essential. Complex reward design. Choosing the right reward function is difficult. One study showed poor results using Sharp directly. Final thoughts basically are RL models from DQ and SSC have shown impressive backtest performance, often stronger than passive benchmarks. Real world success depends on avoiding overfitting, setting appropriate rewards, and frequent retraining. These methods are gaining traction in crypto, futures, equities, and macro markets. So that's it, guys, on the reinforcement learning models. Thanks everyone for joining the call. Have a nice day. Bye.